Good evening, everyone. Let's get started. So the outcome of the Twitter poll that I did showed that people wanted me to do reversed of dictionaries, which is a new feature in 3.8. And it was a very tight race with implementing sys except hook, unraisable hook, which I might do next weekend. So let's actually look at the 3.8 documentation, what the feature is actually about. Hi Tobias, hi Matti, nice to see you both again. Reversed. So it's about this feature here. Dict and dict views are now iterable in reversed insertion order using reversed. This is the bug report. Reversible dict. I mean, the idea behind this feature is that since a couple of versions, the CPython has been following PyPy's lead to make the dictionary's insertion order stable. And so it only makes sense that now that the dict have a fixed order, which is based on the order of insertion of the keys, it makes sense to actually have a reversed iteration for the dictionaries. And yeah, and I think that's one of the few remaining features that ordered dictionaries had over regular dictionaries. Okay, and so we don't really have that yet. Let me clean up a little bit. Okay, so let's first play around a little bit with the feature. The idea is that if you have a dict and you add some keys, a third one maybe, and if you iterate over them, now since 3.5 or something, the order of iteration is stable. So if I say for key in D, print key, then the order that we get the dicts in isn't based on the hash values as it used to be. Instead, it's based on the order of the insertion of the key. So we inserted 1 first, then 5, then 12, and so we get them in that order as well. And now that the order is stable, it makes sense to allow something like this. Reversed D, print key, and then we get them in the opposite order, 12, 5, and 1. Right, very good. So, oops. Right, so let's talk about how dictionaries work in PyPy. Dictionaries are a little bit, are actually have a pretty complicated implementation in PyPy. And the reason for that is that we specialize them based on the keys that you store. The same is true for lists. So a list that only stores integers is represented in memory completely differently than a list that stores different kinds of objects. And let's observe that in PyPy. To be able to observe the internal state, there is a special function in the __PyPy module, which is called strategy. And that allows us to sort of look into the internal details of the implementation. So if we make a dict, we do the same stuff that we did above. It's important to use exactly the same numbers. No, not really. Right, and now if we call strategy on this thing, it will tell us that it's an integer dict strategy. So it's a dictionary that works particularly well for storing integer keys. And the specialization works on the keys for dictionaries. And the reason why that is cool is because now the hashing is much more efficient, because now we know that all the keys are ints, so we don't really need to look up some __ hash method. We can just always use the value of the integers. Right, but of course the strategy can change, so the internal implementation can become different if we now mutate that dictionary. For example, if we add a float key, it's really about the keys. So the fact that I'm using none here, that doesn't matter at all. But if I'm adding a float key, then the strategy is, it's not what I expected. It's object dict strategy, right? Okay. So for lists, there's a special optimization that where we can store integers and floats together in the same list, but we don't have that for dictionaries. So if you add a key of a different type, we switch the implementation strategy, and from then on, we cannot assume that all the keys are of a fixed type. By the way, this is a one-way street. So if we now say del, right, now the strategy is still object dict strategy. So yeah, so I mean, that is one of the things that will make our lives a little bit harder, because there is a number of these strategies, and we need to implement the reverse iteration feature for basically all of them. Right. Let's just I mean, this is a detour, but let's very briefly look at lists too. So if you have an empty list, then it uses the empty list strategy, and then if we append stuff, numbers, our first negative number, then it switches to an integer list strategy, which is more efficient at storing integers. In particular, it will store the integers in an unboxed way. So it basically, it really stores the machine words that containing the values of the ints without any boxing, without any extra memory overhead. Right, but for lists, there is really this special strategy that says that, oh, if you add a float, we can still store them in the same list using an int or float strategy, which is slightly less efficient than just ints or just floats, but it still is much nicer than using an object strategy where everything needs to be put into its own little memory object, right? And only then, if we add a string, then we give up, and the strategy is object list strategy. Yes, Panos is asking whether there isn't a convenient base class where we could add that feature. Yes, that's correct, but there's a typing problem. I mean, we run into problems with the fact that our Python is statically typed, and there is a big meta programming mess that we will encounter very soon that makes this quite difficult. But yes, I mean, if we were implementing this in pure Python, it would probably we could put it into the base class and be done with it. We can still put some stuff in the base class, but then we will have to do a little bit of extra work for all of the strategies, I think. Okay. Right. Actually, we can grab for how many strategies there are. What's the base class of the strategies called? Class dict strategy, that's the base class. So we can grab for subclasses of that. Dict strategy. Right. Okay, this one is not a real file. A bunch. 1, 2, 3, 4, 5, 6. There's some more, but I mean, there are quite a few of these strategies, and we'll talk about some of the more complicated ones later. The first mental model is really that they are there for for storing different types of keys. Okay, let's get started. Let's start with the tests. Okay, what kind of iteration is there? Oops. Right. Iter items. The test is still named after the Python 2 method name, but of course now we can just call items. Right. And let's just have a version of these tests for reversed iteration. Right. Here we hit our first surprise. The first surprise is that there is a test called reverse dict. So we already have some code somewhere that allows us to do reverse iteration, but it's not in the obvious way. We need to use some kind of special method in the PyPy module. Okay, that's good to know. Let's actually try that. I'll start the PyPy again. So what this code is telling us, that if we write a dict like this, and if we iterate over it for key and d print key, we get the expected order, but it seems there's already some kind of weird internal helper function that allows us to, what was it called? Reverse dict. That allows us to iterate in the opposite order, right? Cool. So the code, I mean, the hard part is already there. The hard part is already in this weirdly named internal function. I'm actually going to grab a little bit soon what it's needed for. I'm not completely sure. And we just have to sort of rearrange things slightly so that we use that machinery for reversed. Okay, actually, let me remind myself how reversed actually works. If we have a dict, there's a special method reversed, right? Right, okay. And that's what we need, right? So we need to implement this special method, basically, to get the effect that reverse iteration works. Okay, first the tests. So we will keep this one and just add versions of all of these. Oops. So and actually I want somewhat simpler tests. So let's say, okay, assert list of reversed of d equal 3 and 1. I think that's the very first test we want, and then we want another one that says with the keys, and then here for values. Oops. For values, the same thing. Assert list reversed of d.values equal 4 and 2. And I dislike this order of test methods. So, and now items, and items should give us a list of reversed of d.items equal 3, 4, comma 1, 2. Okay. Right, good. So I think that's our first goal. Let's run the test, and it should just fail. Right. Stuff is happening slowly. As usual, when streaming, waiting for the test feels much longer as when I do it on my own. Right. And while we wait for that, right. Okay. Okay, there are two subclasses of this test class, so we get, what's the dict? object, multi-object, I don't know. Doesn't matter. But we get this obvious error. Argument reversed must be a sequence. And what that means is that there is no reversed special method. Right. So where do we add that? We add that here basically. There's a dict multi-method type def. The type def is the type definition for all the methods that are visible to the Python program, and the goal here is to add something like reversed. Reversed, right? And now we look for the implementation of that here, and we add a new method here. Right. And we can now look at how to implement that by looking at what this weird method that we discovered exists does. So let's look at the implementation of that, and that should be in PyPy, I'm not quite sure in which file, reverse. It's in interp dict. Right. Okay, so here's enumerate the keys in a dictionary object in reverse order. This is a PyPy function instead of being simply done by calling reversed for CPython compatibility. The dictionaries are only ordered in PyPy. Right. So this is a very old comment. Right. Okay. So now we figured out what it's for. It's there because in PyPy an ordered dict is simply a dict, and it's a dict, maybe even a subclass of dict that implements reverse by using this special method. But of course now in 3.8 all this is slightly less relevant, because now in 3.8 regular dicts have a reverse, so we don't need that detour. We will not remove that function, but maybe we can stop calling it from order dict. But I mean that's a later problem. Let's look how it actually works. So it calls an internal method called non-desker reverse dict, and that is here, right? So what we do now is we can turn this non-desker reverse dict into a desker, like into a completely regular exposed method. So we rename it. Maybe we can move it to where we just were, or maybe not. I'm not moving it to make merging easier later, right? But that means I don't need this thing, and instead I can call reverse dict here. Right, good. So what does it do? So yeah, let's actually put a PDB here and look around a little bit. So if we run this now, we have a reversed method. We added a reversed method to the type def, and we are calling the existing infrastructure for reversing a dict that was exposed in this weird special function. So if we call that, and I added a PDB to be able to inspect a little bit what's going on. Let's see. Right, so now we're in the debugger. So let's look at self. Self is a dict object, and it's a dict object using an integer strategy, and we can inspect a little bit how it works. It has a strategy, a D strategy, no, what's it called? I forgot what the attribute is called. So it has a get strategy method which will return the strategy, and currently it's an int dict strategy. And then it also has a D storage, and the storage is basically a block of memory that that depends on the current strategy that contains the actual content of the dictionary. So if it's an int dict strategy, it will contain a dictionary mapping unboxed integer to boxed objects, right? And then there's this weird erase around, which is a technical detail about RPython. We're going to ignore that for tonight, I think, right? But that's the two essential fields. Okay, I want to know what the attribute is called. No, should be called dStrategy. Why is it not called dStrategy? It is. Okay, good. So it has two fields, dStrategy, which stores the strategy. The strategy is a singleton. So every instance of dictionary that has an integer strategy will reference this object, the same object. And then the storage is owned by the wrapped integer, by the wrapped dictionary. Sorry. Right. Okay. So where were we? To implement the reverse dict, we get the strategy, and then we call a method on the strategy, passing the object as an argument. That's a pretty common. I mean, that's how the strategy pattern works. We have the strategy, we call a method on that, and then pass in self. So step. Right, and then iter reversed is a method on the int dict strategy, and what it does is it creates an iter object, a keys iterator, which internally stores an iter class reversed, and right, that calls get iter reversed, and that calls some internal helper function. Okay, that's pretty indirect. Maybe we don't have to care so much about how all this works, because I think if we continue, damn. Okay. Right, the test still fails. Test still fails for different reasons, but we get further. I mean, before this was the line that was failing. Before we couldn't call reversed on dict, but now only the second line is failing because we can't call reversed on the keys view. But the dictionary itself already is a reverse iterable, which is cool. That's a great first step. Right. So let's look at how keys works. I mean, we can't quite commit yet because not even the first test passes. But the keys, doing the same thing for the keys view should be easy because we can just do the same thing. So how do keys work? Right. Keys calls Desker keys, and that makes a dict view keys object. Okay. Here. And that inherits from dict view object and set like dict view. Okay. And here's the type def. Right. So here, that's, as I said earlier, the type def is the description of what the type looks like to the Python level. So that should have an iter, and we will add a reversed here. Right, same approach. Let's look at what the iter does. Right, dict view keys object. Desker iter returns a dict multi-iter keys object, calling the iter keys method on the underlying dictionary. Right, that makes sense. So what we need to do is we need to add a Desker reversed, and here we need to call some method on the underlying dict as well. But I forgot what it was called. Maybe we can scroll up here. Like this. It's not a method yet. Maybe it should be a method. But let's try whether this approach is actually correct. Right, I think this has a decent chance of working. So iterating over the keys view or over the dictionary is basically the same. So I think we have a good chance of this just being correct. Okay. Oh wait, I still have the PDB. I don't want to step through this stuff again. Right. Bye, Matti. Bye, Tobias. Ah, sorry. I read stuff in the wrong order. Matti is staying. Bye, Tobias. See you next time. It still fails. Oh no. Okay, idle class reversed is failing. I'm not doing the right thing here, I think. I think we want these two lines instead. Here, something like that. Wait just a second. Right. And that's the iter, and we pass that in here. And we still have to do that. This should be a method. No, it's not an import, I think. It's all in this file, but what was it like? It's iter class reverse, but it's right. See, it's not a global. It's basically this meta-programming function create iterator classes that we call once per strategy. But then we only get this local class definition, and it's not globally reachable. Right. Isn't maybe this is the thing we need? Reversed. Let's see whether it works. Oh wait. Right. I think it works. I just need to restart. Yeah, this, I mean, several of the, I mean, the tasks for 3.8 are getting slightly more annoying. I mean, I started with some of the very nice and easy ones, but this one is actually relatively complicated. I mean, as you can see, the file is already close to 1700 lines of code, and it's quite intricate and complicated. So it's not really the easiest code to change. And there even, I mean, it's not all in one file either. There are other files that implement dictionaries. So it's always a bit of a mess to sort of get an understanding of what's happening. Sort of completely accidentally, I had to look at the file today as well, right? I should just do this method thing because I'm just sort of, I'm not thinking properly and just doing random stuff. This should work though. Famous last words. Let's try. We don't really have a schedule for 3.8. I mean, hi Batuan, by the way. It depends on you and I, right? Batuan was asking whether we have a schedule for 3.8. I mean, I think I think the schedule is it's done when it's done, and currently there's the two of us working on it, so that's not a lot of people. As I said, if anybody else is interested, please join us. It's a relatively nice way to start with the project, because yeah, there's still new stuff to implement, which is much nicer than sort of having to look at bugs or doing complicated things. No, I'm confused. I didn't save. Yes, of course. Great. I mean, I definitely hope that when is 3.10 coming out? Yes, the banner is pretty cool. Please give your thanks to Panos, who is also there. I think. Yeah, I would kind of hope that we have an alpha for 3.8 before 3.10 final comes out, CPython 3.10, so that we're not, I mean, that we're not falling further and further behind. Right. Okay. I'm doing something wrong here. I don't quite know what. Okay, this is just doing random stuff, and I shouldn't do random stuff. Okay. I will be more careful and right, thanks. Okay, let's look at how this works. It calls strategy.iter reversed, and strategy.iter reversed is implemented like this. And why can't we do this? Self.wdict.desker reversed dict. It's slightly confusingly, they have different names. Does it take arguments? Yes, a space. I think that this should really work. But I said that like 7 times already, so. We're still going to have all kinds of problems, by the way. Let's see. Because one thing that is a little bit different now is that I think in CPython, what's the type that you get here, right? You get a dict reverse key iterator. And I think for us, right, good, the test passes. But I think for us, the type is the same. Let's try. I'm starting this, it takes a while. But I think that the type of the iterators is the same, which I don't particularly care about. I mean, I don't really mind, but it's possible that there's a CPython test that checks the name of the resulting type, and then we'll have to do work. But for now, I'm going to ignore this problem because yeah, it's basically a surface issue only. Right. So we have dictionary iteration. I mean, we have reverse dictionary iteration. That means we can iterate over the keys view as well. That's good. And it was easy because we only had to rewire the already existing machinery. And for consistency's sake, I'm going to rename that because otherwise it's a bit weird, right? And then I also need to check that the previous code around that still works. So I should go to module PyPy and run the tests there. Fantastic. There isn't really a test here. Maybe it's in... Ah, yeah, it's in here, of course. We saw it. It's here. This one. We should run this test too. Reversed dict. As opposed to just a list, or what do you mean? Panos asked why they return an iterator. We're waiting in parallel again. Very efficient. There's no I don't think there's a specific reason why CPython needs to return a different type. I think they can't do it differently. For them, it would be, I mean, PyPy is very good at pretending that two different internal things are the same type to the user. But CPython doesn't really have that ability, so they need to return two different kind of things. Whereas for us, there is a generic dict iterator kind of thing, and we can either internally give it a reversed view or a regular view. So yeah, does that make sense? So wait, I can. So here we have the so iter reversed returns a dict multi iter keys object, which is the same. Oh no, it's not the same as iter class keys. I thought it was the same as the keys iterator. I'm just lost in a. I mean, every time again, I'm lost in this sea of auto-generated iterator classes. What is this then? Is it the base class or something? I don't know. The tests are passing. I'm happy enough with that for now. Right. Let's look at the diff. Right, we renamed the existing machinery because now it's not a non-desker, it's a desker. That's just a naming convention, by the way. It's the descriptor. And then we added a desker method to the type, a reverse method to the type def that exposes that existing machinery. And the same is true for the dict view, for the keys view. Then we added some tests. Okay. Step 1. Let's commit it. Right. Good, great. I think there was which comment isn't right? Tobias says there's a comment that's wrong. Ah, thank you. Yes. We should add the docstring of reversed. So Python 3.8 help dict.reversed. Okay, great. Yes, thanks a lot, Tobias, for catching that. Didn't you just say you were leaving? I mean, I'm happy that you're still around. This is still starting. Well, everything feels a little bit slow, but maybe it's just Twitch taking lots of OBS taking lots of CPU again. Am I doing fine on disk space? Yes, excellent. I'm recording to an external hard drive today to prevent the problems of last week. Okay, so that was the easy part, unfortunately. So now we need to think about values. Right. Okay then. Right. So let's look at the values view. So that's the values object, right? That's the values view. And it has an iter implementation here. Right. Where's the class definition first? Here. A bit confused. That's not what I was expecting. That's not the view. That's the iterator. Okay, I'm looking for the view. Here are the views. Okay. That's the items view, and that's the keys view. We're good about that one. And that's the values view. And right, that's the class that we're looking for. And that returns a dict multi-iter values object, right? So the view returns a values object, an iter values object with this argument, right? So what we want is we want to expose a reversed method here. Maybe. I'm not entirely sure. As I said, this is very much a sea of classes. But the goal would be to have this, right? Right. So that's the easy part. We hook up the reversed method to this method, but I'm not really sure what should be happening inside here. So let's understand how iter values work. Right. So iter values is iter values is returning an instance of this iter class values, and I'm not really sure whether we need a reverse version of all of these classes or not. Multi-iter values object, right? might have to add lots of auto-generated classes here. Right. Okay, let's see. So let me try that. There's so much meta programming here, and it's every time it's really very confusing. What does this new next thing do? Calls this. I'm lost. I admit that I'm very lost, even though I fear I even started this file. But I think I'm going to try to somewhat mindlessly copy this reversed iterator. And it should look a lot like the value iterator. And then we create iterator classes for every strategy. So let's create another class here. Iter class. What did I call the previous one? Value reversed. Okay, let's call it values reversed base. Right. Need to call the right base in it. Our Python doesn't support super. That's why you need to call it explicitly in that way. What is override next value? I do not know, and it's not passed in here. Okay. I don't know what goes here. Yes, this is all quite annoying. Right. I think here in the init we need to do something like strategy.get iter reverse values. Right. This looks plausible. So what do we do with that? Iter values. So that means that def iter reverse values self wdict return iter values reversed self.space self wdict. Right. So what happens with that? We stick it into the dict implementation. So let's do the same thing. Iter reverse values. Call iter reverse values. Right. Great. So now the remaining question is, what is this? Right. Okay, so now we need to implement the actual iterator. And I'm not sure how that works. Okay, this is where the whole approach of just blindly copying what iter values does is crashing, is going to come crashing down. Because iter values is implemented in terms of the RPython level iter values, but there is no RPython level reversed iteration. There is only this one special thing that that only returns keys, not values. So we need to sort of paddle back a little bit. The whole idea of just blindly copying what we did so far is not working. I mean, I should have, basically some thinking up front would have been better than just sort of trying to figure out what the existing code does and sort of copying that. Right. So let's undo this a little bit. This is still right. This is still good. But the rest of the copying was wrong. Okay, that's too bad. So we're back here. Does CPython use a special type for the reversed of the keys too? It probably does. For the recurse of the values. Right. So there's a special type for each of these. So maybe for the value we anyway need a special type. And then if we define one here, okay, thank you, Matti. Matti says there's one for items too. So maybe we actually have to go and have a reverse value iterator anyway. Okay. So that would mean we say dict multi iter values reversed object. So it means we just have one new class and not the whole host of new classes. But then this one can actually take the existing iter reverse thing, I think. This one, iter class reversed. Yes, and then we get the key and look up the key, which is slightly less efficient than just taking both, but at least it works for now. Actually, before I dig a lot further here, I would actually very much like to know what does collections do. So there is an ordered dict here, right? How does ordered dict values return implement reversed? Right, okay. Right, it's inefficient in the same way. So this is now regular Python code, not RPython code. So here's the implementation of ordered dict, and it's just a subclass of dict because all dicts are ordered anyway in PyPy, as in CPython nowadays. But it implements reversed in the way that we already read about a few times, by calling this special function from an internal module, and then the values view and the items view have a generator to turn that into into an iterator over the values, right? I don't quite get why this is done here. Shouldn't this be equivalent to that? I mean, if you just say yield from an iterator, you can just return the iterator, right? Is there any flaw in my thinking? I mean, it doesn't really matter for our current task, but I'm slightly confused why it's written that way. I don't get it. I'll add this comment. Let's not commit it, but yes, but Python 2.6 doesn't even have yield from, so that can't be the reason, I think. But yeah, maybe it's something. Maybe it's some old backward compatibility thing. I leave that as a comment for me to look into later. Okay, so what we found out is that order dict is slightly inefficient in that it iterates to iterate over the values. It iterates over the keys and then looks up each key, which is a fair enough approach, right? So we can use this iter class reversed and use next key entry, and then in the wrapper around that we will take the key that we get, look it up in the dictionary, return the value. And that's slightly less efficient than directly doing the good thing, but it's still pretty reasonable. So where were we? The goal is to write this function. It should be sort of in the general vicinity of this thing here, maybe here. So now we call the next key, because the underlying reversed iterator is a key-based iterator. So we ask for the next key here, and if the key that we get is none, we raise a stop iteration. That's fine, but if it's not none, we say return self.wdict.get item, I think, and that probably takes a space and a key, right? That could work. Yeah, we have an not entirely sure. We don't seem to have a wdict here. Maybe we simply store one. Yeah, there's a host of problems. This is really not an entirely trivial task. We also need to think about pickling later. Fantastic. Right. Let's see. Let me actually see whether we get here. So what we want to run is test. What was the test called? Reverse values. Right. Yes, I'm already stressed out by this task. Let's see. There's interesting notes about how pickling works. Okay, no, we don't get here. Okay, so I'm doing something wrong. Yes, I know what I'm doing wrong. That doesn't exist. Reversed. It's just called maybe I'm going to do I don't know. I want this thing again somehow, but I can't get at it. Okay. Yeah, I will not finish this. It's already becoming clear. This is also very inconsistently named, because so the iter items thing returns an internal iterator, and the iter reversed method returns a wrapped iterator. So maybe the first thing to do is be more consistent here. Let's rename that. Right. And then we can have a reversed. We can use the old name for just this part. And here we can call that function right, and we stick it in there. Right, and now yes, that's kind of what I'm trying to do. So I'm I was maybe too quick about that. Matti is asking whether I can't implement the reverse values iterator to use the reverse dict iterator. I can't use the existing values iterator because the existing, let's look at the existing multi-iter values. The existing values iterator expects to take an existing inner values iterator, and it calls next value on that and just returns it. So we can't use that to wrap the reverse key iterator because the reverse key iterator doesn't have a or maybe you're much smarter than me. maybe Matti, you're onto exactly the right idea. Wait. So let's look at this thing. Yeah, I'm not sure it works. So because this inherits from base key iterator, and so yes, indeed, we could implement a next value here, and then it might just work. But I'm not entirely sure that the base key doesn't have strange restrictions that I'm not really thinking about. Let me actually try to continue with my approach for a little bit further. Multi-value iter values reversed here. Right, and now we have this class, and it wraps a keys iterator. That's kind of my goal. And let me look at one last thing. That has the dict, right? Okay, now I know what to write here. Iterator implementation dict.getItem. Right. This might have a chance of working. Right. So the idea now is that to implement a reverse iteration of the values, we pass it the reversed. What did I just call the? This file is simply too big. I keep searching for stuff. Here. Iter reversed. Right, and the iter reversed is a reversed key iterator. And so now to implement the values, we instantiate that by passing it the reverse key iterator, and then the next method of that will look up the key in the dictionary to produce the return value. That's slightly indirect and less efficient than it could be, but at least we might be able to do it. And now we need a type def. So for the values reversed object, we need a, what was it called in CPython? Reversed dot values, reverse value iterator. So that's the new type that we're defining, and right, it calls these things. Oops. And for the length hint and the reduce, we can use the base implementations. That's great. Okay, let's try this. Okay. Yeah, this is a bit of a slog tonight. I should probably not even do it directly on the 3.8 branch, because I'm fairly sure that it will break stuff. What did I call it? Ah, no, there's still iter values. Wait, where am I? Sorry, I'm getting lost again. Where's the actual dict? Ah, yes. We need to add it to this special other meta-programming place here. Not completely obvious. Now we lost another minute. Yes. Yes, this is all very nice and gives extremely, I mean, it gives really good performance improvements for dictionaries with certain kinds of keys, and it's also used to implement instance dictionaries, for example. And particularly for instance dictionaries, it's extremely important to do it that way, because storing them as hash maps is incredibly inefficient. But the code is not exactly fun to work with. Well, I think that might have been it. I kind of hope that might have been it. Right, I added a PDB. Right, okay, so we are in the next, so we managed to successfully create a reverse values iterator, right? That's good. So what we're now in the next implementation. So we have an iterator, and that should be an iter class reversed. That's good. So, and that has a next key. So if we call next key here, it will do complicated things. I will explain what these complicated things are, but it returns the 3, which is the first, I mean, it's the last key, right? So now we have the last key, I mean, and then we ask that to look it up in the, and of course I called it with the wrong signature. That's fantastic. Not. It doesn't take a space. Sorry. Where's the PDB? Okay. It looks like this. I think it's looking pretty good. I don't think we need to step through it again. I think this has a pretty decent chance of working. Right. And while we wait for that test, we can write pretty similar code for iterating over the items in reversed fashion. Right, like this. And to do that, we look up the value, and then we can take this code here to create a new tuple consisting of the key and the value, right? Items reversed object, right? And then now we need to define the type. Right, we need to figure out what the type name is, but I suspect it's that. And then here, instead of values, we need items. Good. Okay, getting there maybe. And this, what does the tests do? The tests pass, fantastic. And that this, we are not creating that anywhere yet. We need to create that in the reversed, where are the views? We need to create that in the reversed methods of the, here, desk reversed. Let's put it next to the iter. Yes, and let me actually look at what we did for the key, not for the keys the easy case, for the here. And the only difference is that we need to use the items. Right. And now we need to expose that by going to the type def and saying reversed equal reversed. Okay, so this passed, and reverse items is the last one, I think. All right. That was somewhat painful, but it seems we might still be getting somewhere now. Cool. Okay, let's run all the tests. We don't need that anymore, I think. Wow. Startup time, 10 minutes. Right. Yes. Bit annoying. We renamed some stuff. We added 2 new iterator classes that iterate over the keys in reverse order and then either turn them into a value by looking it up, looking up the key, or by looking up the key and then making a tuple. And that should work. But there's still some unclear parts. I mean, there's one unclear part here. Oh no, I deleted that, it seems. Has that reversed? So it seems that there are some implementations that don't support reversed iteration. Right. What is that for? Is that used anywhere, or did somebody just not delete it? Seems like a remnant. Yes, let's kill it. What about has pop? Maybe that's still around on default, but on, let me actually check that out. is it called? Iter reversed. Yeah, it seems not needed on default either. So we can delete it, and we should actually delete it on default as well. That seems like that's something that's left over from a previous approach. Right, and so there's one problem, which is that there is this strange fallback here, which says that some of these dictionary strategies do not implement get iter reversed, and what it does then is it uses the reversed of the dict of the list that you get if you call keys. So you turn the keys into a list and then use the reversed iterator over that, and we don't support that so far. So if there's no get iter reversed, right, then we will not add this method at all, and then we fail. And I'm not quite sure what to do about that. Right, what are the tests doing? The tests passed though, right? Let's actually check that in, because it's a good intermediate step. First step at implementing a reverse iteration of values and items dict views. Right. So now we should do more complicated things, right? So who has a get iter reverse? What is it called? First. Only things in here. So strategies that aren't in this file are potentially broken. Maybe we should write a test that checks that. So the first interesting dictionary implementation that is now probably broken is module dictionaries, and they're in a file called dict, and we should also open the tests for that. All right, and what dicts are. They're basically version dictionaries. We talked in the last stream about the logs language. We talked about versioning, and we versioned the modules there, and the PyPy module dicts are versioned, and that's what the dict is about. And it doesn't have a reversed implementation, right? So we can see the problem by, I mean, this is what the module dict strategy looks like. And it has this version field, and it changed the version of the module dictionary changes whenever the dictionary changes, and in that way the JIT can remove the lookups in the module dictionaries completely. So basically, when you look up a global that is compiled into 0 code by the JIT, it really just the value of the global, which is really good, and only if you mutate the value of that global, will the code that depends on that value will be invalidated using something called de-optimization, which is a fairly standard JIT technique. But basically, reversed iteration of module dictionaries is now somewhat broken, and we should verify that problem by writing tests for right. So there's a reversed implementation here, and basically, that's very minimal. I think we can do better. Ah. Okay, Matti says that on CPython the reverse iteration of the class dictionaries is also broken. Matti, you should absolutely file a bug for that. Let me try. So what you're saying is that this is a weird mapping proxy, and if I say reversed of that, it's not reversible. That's too bad. And but I think for modules that's probably not true, right? So if you say import sys, you can definitely say reversed sys dot modules. Okay, so somebody already Batuan is saying that somebody added it later. So in 3.9, do I have 3.9? No. Right. So it's added in 3.9. So great, but not our immediate problem. What I'm much more concerned about is basically, okay, great. So it seems it was added. Thanks for looking that up. Let me actually look here. Right, and that was added here. Okay, great. Okay, so we'll have to do that later in 3.9. Test reverse keys. Right. Let's start with keys, because I think keys shows the problem. If we solve keys, the others just work as well. Right. So it's a little bit more complicated because we need to create the dictionary in a slightly weird way. I mean, we create it in that way, and then we get something that looks exactly like a regular dict, but it uses the special versioned module dict implementation. And what we want to have is that if we say assert list of reversed of D, that should be def, comma, abc, right? I mean, that should work. And then I suspect that the first line works, but the second line might not work. Let's see. So if I run this test in right. So we're not, I mean, I was kind of losing hope in the meantime, but it seems we are making some progress. I mean, for the reasonable dictionary implementations, we got it, and now we need to think about the somewhat more obscure ones. And I think for the more obscure ones, it's not important that we are efficient. We should get the behavior correct. But let's first observe the problem. Ah, yes, that's annoying. What's going on here? There's probably more keys, right? Probably the dict adds a name or something, right? That should not be confusing and say X, Y, Z. To not mix it up with the name of the module. Right. Okay. So waiting. Yes, it's somewhat annoying that assert reinterpretation is broken for application level tests on the 3.x branches. Because we're running PyTest on the underlying Python 2, and yeah, that version of PyTest is having a hard time reinterpreting the asserts of the upper Python 3 code. And that's a bit of a misfeature, but nobody ever had the fortitude to go and fix that. But it still annoys me every time, because it means that if you get a failing assert, it doesn't tell you at all why the assert fails, and yeah, that makes it a little bit annoying to use. Right. We're doing our minute of waiting. Yes, Batuhan says that it annoys him too. Right. Okay. So there's all kinds of stuff added to the dictionary keys, and so we should filter that out. Let's say key for key in, if not key that starts with, we just care for the regular key. Actually, Batuhan, if you ever feel in a somewhat weird mood and want to investigate that, I mean, in theory, on Python 2 it worked, right? On Python 2, the assert reinterpretation was manipulating the upper level ASTs to do the right thing. And the problem is just that the ASTs aren't compatible enough anymore. So if you want to do some very strange hacking at some point, then feel free to look into that. It would be incredibly useful, but I'm not sure it would be. I mean, it might not be enjoyable. Right, waiting again. Wait, of course, I still didn't fix it for... I didn't fix it for the second part of the test, d.keys. Yeah, the tests feel particularly sluggish again tonight, but I think I have the feeling that I say that every week, so maybe it's really just sort of the stream related time dilation. Right. It worked. So this one worked. This one didn't because we didn't fix it. And we didn't fix that either. But it seems it worked. I'm slightly impressed. I was sort of expecting that to not work at all. Because there is nothing about reverse iteration here. Maybe this fallback is better than I thought it would be. It's always annoying if stuff works for unexplained reasons. So we are very much expecting this not to, I am very much not expecting this not to work, and it does. So let's actually make sure that the dictionary is still a strategy d equals cell dict, what's it called? Module dict strategy. Let's make sure that it didn't in the meantime convert somehow to some other kind of dict strategy, and it passes for that reason. I mean, it's fantastic that it passes, but I would like to understand why. I mean, I don't. Maybe we should try an even. Oops. Yes, it's not completely my evening. I just wrote :W into my shell. Okay, let's keep that running. Let's look at one of the even more complicated ones, or even more weird ones. So there's a keyword args dict, and that's basically created when you call a function that takes ** keyword args. And so if you have code like if you have code like this and you return the created dict, it will use the keyword args dict strategy. And we can check that reversed works here. There's no test about reversing here yet. We can write one while we wait for this. By the way, if you've never seen this kind of style of application level test, so the underlying Python file is in Python 2, but the code in the test functions is Python 3. So you can only write tests that are sort of in the intersection of the two languages. But of course, sometimes you want to test features that really need Python 3 syntax. And if you want to do that, then you can write them into a docstring. Reverse. So this is the way that you make one. Args and then assert list of reversed of D should be A, B, C, right? No, wait, the other way around. C, B, A. And keys should be the same. And let's just be complete because we're waiting for the test anyway, which passes for not completely, as I said, still not completely understandable reasons to me, but in any case, I mean, if the test passed, that's, I mean, I'm going to take it. If the test passed, then at least we wrote some useful tests. So that should be C4, B3, and A2. Right. Okay. Let's run those two. I mean, I'm not complaining that they pass. I'm just really not expecting it, and it means that yeah, there's something about the code that I don't completely understand, because again, there's nothing about reverse iteration in here. So this is the strategy for keyword args, and then there's a strategy for, while we're waiting for the test, we can look at some of the remaining ones. There's a very strange one called JSON dict that you get if you unserialize a JSON string, and you get an instance of that, and it has some advanced support for I mean, the observation of if you have lots of JSON files is that the keys of the dictionaries repeat a lot, because usually I mean, they represent some kind of object, so you want to make use of that structure that exists in JSON files, and so we have this strategy here. Right. Okay. This is the failure I was expecting to get also for the module dict. So for the keywords args dict strategy, I'm getting this error, iter reversed. It's not there. And yeah, I don't completely understand why I'm not getting exactly the same one for the module dictionary. But maybe we can focus on how to fix it here. So maybe we can implement a slow fallback implementation that works for everything. And I think there is one, but it's on the slightly wrong level. So this is the fallback, and what the fallback does is it creates the dicts, it creates the keys as a list and then calls the reversed method on that, which is slow because it needs to build this list. But in order to support reversed iteration for stuff like module dictionaries or keyword args dictionaries, I don't expect there to be a lot of calls to reversed for those. So maybe we can do the same thing here. And I don't quite know what it would look like. No, it's not called. It's called get iter reversed. Right. And that's now really returning an RPython level iterator. It's entirely possible that we're going to have bad RPython problems here, but I'm going to try to at least get the behavior right now. Right. So the approach could be we get the keys. Isn't there also keys? Right. We get the keys, then we unwrap them. Space dot unwrap something. What's it called? List view maybe. And then we can say return. Ooh, maybe we can't. I don't think we can reverse that here. No, I think I'm stuck again. I'm stuck again at implementing this in a generic way. Maybe I think, yeah. I don't know. At this point, I unfortunately don't know. I mean, one approach would be to implement the w-iter reversed for all the strange subclasses, right? That would certainly work. It's just a bit more work than I kind of wanted to do tonight. I was kind of hoping to write a fallback, but I don't really see how I can easily do that. Yeah, I think I'm going to finish. I think I'll leave that for myself to think about later. Let's look at the Did I close the right? Okay, let's look at the diff. We didn't really do more. We wrote some tests. Right. I should really also very much not push that to 3.8. I'll after the stream ended, I'm going to move the commits to a more proper branch and then push that. Right. Yeah, I think I'm going to finish now. Sorry that I was stuck a lot. I mean, it was more complicated and much hairier than I expected it to be. Yep. I can show you, but I always Google it myself. Move commits to branch. I think you strip them and then you re-import them. Sorry, I don't really. I don't really have a. Right. So if you didn't push, it's not so annoying, right? If you push, it's much harder. But if you didn't push, you can graft them, which is basically like cherry picking them, and then you strip them. So let's look. There's still this. I don't care. Shelf is like the git stash. So now I say out. I think THG is broken for me. Yes, I'm not entirely sure whether I can still apt install that. It's called Tortoise, I think. Search. Right. Yeah, I'm not doing that now. But he says that we have to install Tortoise HG from source. Or is that just a pip install? I'm going to show the manual way. Maybe I should learn THG. So right. So those are the 3 commits, and I should update there, which is the commit before. Now I should make a branch, Py 3.8 dash reversed dict, and I will graft the oldest one, this one, right, and then this one, and then that one, right? And now all the commits exist in 2 variants, both on the 3.8 branch and on the 3.8 reverse dict branch. So now I strip the unpushed commits. So I can say let's list them again. Strip. Yeah, strip is useful to know. And stripping you should strip the newest one first. Maybe strip does the right thing and just strips the dependent commits as well. I'm not sure. It probably does. Mercurial is fairly safe. So now we should only have reverse dict. Okay, it seems I forgot one. I hope. Right. Now I can say push new branch, and I will only push the current branch. Right, okay. Now we pushed on a new branch, and actually we can, yeah, no. The CI will tell us in a couple of minutes whether it's broken or not. I have the vague fear that what we just pushed also breaks RPython. Do I get a CI now, or only if I actually create the merge request? So it's definitely running it here, right? For that's the right branch, right? So let's look at what it's doing. Right. It's starting a translation, and I have the dark feeling that what we did will have broken it, and we will get an error about that in a couple of minutes. Okay, yes, we made less progress than I hoped, and I'm going to finish this. Probably not streaming. Let's see whether I find time to do a random stream in the middle of the day at some point. And yeah, Otherwise, I'm going to continue streaming next Saturday, probably at the same time. Thanks everybody for joining me. Next week, I mean, if I don't find time to finish this stuff, and I will finish it. Otherwise, I might do the sys.unraisable hook. Okay, that's it from me. Thanks everyone for joining me, and have a good night.